Hey guys, this is Dogger's Lab, and in this video I'm going to show you how I extracted pure gold from a batch of e-waste that a client sent me that I spent time separating, and I got 171 grams of gold-plated transistors, 537-ish grams of pins that he had separated prior to sending to me, and about 405 grams of pins that I pulled myself from the various components that were remaining, along with 28 grams of plastic-coated IC socket and 304 grams of plastic ICs. We're going to start off by soaking these gold-plated transistors in hydrochloric acid. And we're just going to try and etch away any tin, or lead, aluminum, things like that before we move on with the rest of the processing for them. This is what they looked like after about a week. Next, I'm going to pour all of the pins into one beaker. And I'm going to submerge them in hydrochloric acid. We're going to digest the base metals away and just allow the gold foils and flakes to be caught in a filter. Now, this process could take over a month to complete, but it is mostly passive. So once we've got our pins submerged in our solution, we're going to add some air bubblers. And then we're going to add a little bit of hydrogen peroxide. Start an oxidization reaction with the base metals. Now we're going to add these plastic ICs into their own beaker, and we're just going to add a little bit of hydrochloric acid, just enough to submerge them. And this is what they started to look like after a few days. And this is what the transistors looked like after about a week and a half, maybe 2 weeks. You can see some kind of gunk building up on the surface. And at that point, I decided that it's time to pour all of that through the filter, get some of that contamination out of there. And then I'm going to pour the solution right back into it because there's already dissolved base metals. I want to see what we're kind of working with. I wasn't expecting that egg yolk looking stuff to form. That's ferric chloride or iron chloride, which is a pretty powerful etchant, so I figured I'd let it sit for a couple of days, see what it did. But to my surprise, it really didn't do anything, which was kind of interesting. They are a little cleaner looking, I suppose. I decided to pour some previously used acid peroxide mixture and see what that would do. At this point, I'm starting to think that those drums on those transistors are made of nickel, a nickel alloy. Our little plastic IC sockets are building up quite the film on them as well, so I'm going to try and pour all of that through the filter. Now that everything's in the filter, once the filter's dry, I can use hydrochloric acid and clean even more of those salts out of there. So if there is any gold in our filter, it'll be a lot cleaner. And now I'm just going to pour some fresh muriatic acid on these plastic IC sockets. And I'll add a little bit of hydrogen peroxide. You see the pins are starting to foil up quite nicely. Transistors look like motor oil. You want to keep on stirring these pins though as time goes on. Same with transistors or anything else that you're doing this acid peroxide on, is important to keep mixing. At this point, I'm going to put all the plastic ICs in a beaker, and I'll submerge those in muriatic acid as well. This is going to dissolve those legs off, or at least the tin coating that's on them, which will make processing them later a lot cleaner. I'm going to wrap that in plastic wrap so the tin isn't allowed to react with oxygen. You'll get an insoluble tin oxide. After about another week, I decided it's time to pour the Transistors solution through the filter. That motor oil look is basically telling me it's losing its ability to oxidize much longer. As you can see, there's not much, but a little bit of gold stuck in the filter. So now we're going to make a fresh batch of acid peroxide for our gold-plated transistors. We've etched away the outer surface enough, and I'm hoping that this acid peroxide will be able to punch through finally and start opening them from the inside out. You see all those little things floating around are coming out of those IC sockets. That is our gold foils. So we're going to pour that through the filter. This is all the same filter, by the way. Try to use as little amount of filters as you can, because later they start adding up. As you can see, the sockets are clean. We can ditch those, clean our beaker. This is our pins again. After probably about another week and a half, we're getting to the 1 month marker here pretty soon. Emptying that beaker into the filter. And as you can see, the pins are a little cleaner, but not perfect yet. And there's a lot of copper powder in the bottom as well. So we're going to pour some fresh muriatic acid in there to try and dissolve any of the chloride salts that are sitting in the bottom with those copper salts. Pour that through our filter. If you notice the filter keeps becoming clean in between shots, it's because I'm using muriatic acid, picking out things that are clean, like those little pieces of plastic from the filter. I'm going to pour this solution back in because we've added some hydrochloric acid now. So it should, in theory, be able to go a little bit longer, dissolve some more copper. You see all the little gold flakes floating around in there. So we'll add our bubblers back in. Like I say, I was cleaning the filter in the meantime. See how nice and pretty our gold is looking in there. And this filter was used for like 3 days in a row, and they tend to get soft. As you can see here, as I'm pulling it out of the bucket or funnel, it starts to tear on me a little bit. So we stopped using it at the right time. I'm just going to add that to a big old beaker for later. After a couple more days, the pins really did start shedding a lot of their gold off to the bottom. But we're getting a large layer of passivated copper powder. And the larger pins in there just do not seem to want to let go of their gold yet. So we'll add some fresh muriatic acid. can see how it kind of wants to get dark right away too. It means that there's still a lot of base metal salts in the bottom. But we can see that, so no surprise there. So this is what our filter looks like after a day. I let muriatic acid drip through the filter to try and pull some of those copper salts out of there. And then I'm pouring this fresh solution through the filter. And this is all just to clean those pins a little bit and catch any of those gold foils that were floating freely in there in this filter. And it might be hard to tell, but now you can see the pink of those pins underneath. That means I got some of the crud off of them and into that nasty solution. So now I'm going to make a fresh batch of acid peroxide for these pins. We start by submerging them in muriatic acid. It's got a nice clear yellow color to it. Now we're going to add some hydrogen peroxide. And then we're going to apply our bubblers. My phone battery got kind of low here, so my flash turned off. So I add a little bit of hydrogen peroxide to the transistors solution to see if there's a new oxidation reaction from any weird metals that might have come out. And there is something strange happening. As I stir it up, you see it foaming a lot. I'm not sure exactly what that could signify, but what it does mean is we are oxidizing something. And there's a lot of new gold foils floating around in there, so we're going to pour this through the filter. You just see that big old pile of gold in that upper spot up there. This is what it looks like when it's all cleaned out. So we're going to take that filter, add that to our other beaker of filters. And this is what those transistors are starting to look like. You can see the insides have started to like pop out of them. But when I was looking at them, you can see that there's a little disc of gold still attached to the inside of some of them. And here I'm stirring it up and those are breaking out of there. So we got to pour that through a new filter. And in some of these transistors is like a little disc of maybe palladium or something, but I kept stumbling upon them, just picking them out of the filter as I went along. I added that solution back to this beaker, and after a couple of days it started to look real dark again, like this, so I gave it a stir. And then I poured that through the filter. As you can see, the gold is piling up again, so there really was quite a lot left in those. So we're going to add that filter to our beaker. We're going to wipe that Buckner funnel out and add the little wipey cloth to our beaker. Now you can see that these things are getting much more clean now. This is a fresh batch of acid peroxide. I figured you didn't need to see me make another batch for a third time. And here you can see the pins are passivating a lot of powder into the bottom, but most of the pins are gone now except for the big ones, so I'm going to pour all of that through a filter. Which looks really good. I poured that solution back into a separate beaker, and now I am pouring that through. Or double filtering, if you will. So make sure I didn't lose anything in the solution itself. And the second time through the filter, it drains a lot slower. As you can see, a nice layer of gold has built up, so I'm going to pour a little bit of muriatic acid into our filter now. And that is going to suck through any remaining base metal chlorides, or at least some of the remaining base metal chlorides. And I take the suction off from the pump to just let it drip through after the last few seconds. Otherwise, you'll just pull the muriatic acid through and it won't dissolve the base metals. But we're going to submerge what's remaining in muriatic acid again to clean any more base metal salts out before we move on with acid peroxide again for a fourth time. We're going to pour that through this filter. But each time that we do this, you can see that it gets cleaner and cleaner of a pull. And now we got this nice fat layer of gold in our filter. So now we've got our pins. They're mostly clean, but we're going to add that solution back into those pins because that solution was pretty clean and consisted mostly of hydrochloric acid that time. And we're going to spike it with a little bit more hydrochloric acid. And then we're going to add a little bit of hydrogen peroxide, as per usual. We're going to apply our air bubblers. And now I'm going to add this filter to our beaker of filters. That was a pretty good filter here. And that black dust on that small filter underneath is going to consist mostly of gold, so you never want to waste that. And I always wipe up anything if there is anything stuck to that Buckner funnel with that little piece of filter, and then I come along with a little piece of paper towel afterwards and clean up the residual stuff. So we're going to get a fresh filter and we're going to pour off those plastic ICs solution that we started all that time ago. And this solution is going to contain mostly tin, a little bit of copper, but not a whole lot because we didn't use peroxide, so copper has a hard time dissolving in just hydrochloric acid. But as you can see, our little ICs are a lot cleaner. And we're just going to rinse them with distilled water a few times. And we're going to pour that distilled water through this filter as well, just in case some gold bond wires or something made it into that solution or floating around. We'll catch them in this filter, and then when we go to burn our ICs, we'll burn that filter as well. It was getting really cold out where I'm at, so I've got that red little pipe heater wrapped kind of in an S shape around these transistors and pins beakers, because I think a lot of my problems with how long this was taking was due to how cold it was. It was only about 58 degrees in this tent. And here you can see those pins are basically gone. So I'm going to pour that transistors solution into here. Because the transistors foils are very large, so I'd rather catch those in the filter first and then pour the pin solution into it. That way the little foils from the transistors help catch the tiny little particles and foils from the pins a little bit better. It just makes for slightly more efficient filtering. And then I pick out all of the undesirable pieces from the transistors that got caught in the filter. Those little pink circle things don't really matter a whole lot unless there's still pieces of metal attached to them, which there were not. And now we're going to pour our pins solution into the filter. And this is the remainder of the pins. However, I lost the footage where I was showing the tiny little plastic pieces that were actually holding on to some of the gold pins inside of them. I collected those and just dropped them into that beaker for later. Now I get my ICs into a little steel bowl and I burn them. And I use a little Nap Gas Pro torch to just help get some of them going. Otherwise they're just sort of sitting here grilling. Got me a nice little bonfire. And you're going to want to burn your ICs until they're like a consistent light gray to a white color. Here I use my torch just to kind of get there a little faster. But once you're satisfied with them, then you can move on to blending them. And you're not trying to pulverize them into a super fine powder, but just enough to fit through like a fine mesh sieve filter. And lucky for me, these blended up really easy. In fact, like that outer plastic coating just sort of powderized as soon as the blender got going, which was interesting because it actually left all the interior bits intact. And as you'll see, this became kind of beneficial. So yeah, I just use a fine mesh sieve to separate the powder from the larger chunks. And then I use a little glass stirring rod to just sort of go in circles and push that powder through. It's a little tedious, and it gets really tedious if you have larger amounts of ICs. But for just this small batch, it was not too bad. You do want to wear a respirator when you're doing this entire process. When you're burning these ICs, that plastic dust is pretty nasty. So as you can see here, I ended up with the powder, but then I also ended up with the interior bits of the ICs. And you can see that there's like a gold color to some of them, so I kept them completely separate and formed a plan to process them separately. My usual route with this powder is I put a little bit of dish soap in it, just a couple drops. And then I add some distilled water. And usually I would blend this mixture right now, but I broke my blender when I was blending the ICs, so we're just going to have to stir it. And the point of the dish soap is it breaks the surface tension and allows the gold particles to sink to the bottom. So once you've got the soap pretty evenly mixed, I mean as well as you can, then you're going to add distilled water up to about 3/4, a little bit more, of the beaker's volume. And the reason for that is because we need to decant this liquid off the top with the hopes that we're only pouring the ashes off and not any of the gold. So after stirring, I give it about a half hour to settle. So after about a half hour, you can see that there's still some ashes floating at the top, which is what we want. So we're going to carefully pour just the top fluid off. And you just want to watch the bottom for the mass of the ICs starting to come up. Like that. And you stop before any of it comes out, because that's where your gold's going to be at. So we just do that a few more times. And every time we do that, we're removing more of the ash, which is going to be important later on. So after about 3 or 4 of those pourings, now you can see in the bottom, you can see all these different colored little metal flakes. That's where your gold's going to be sitting. So now that my powder was ready, I added a little magnetic stir into my beaker. And then I added some distilled water, probably about 400 or 500 milliliters. And get that stuff off the edges of the beaker back down into the bottom. It's mostly ash that's sitting up on the edge of the beaker, but so we get our little magnetic stirrer spinning around, and then we add some nitric acid. And we're going to turn on the heat, turn on the magnetic stirrer, and we're going to let that sit for probably a good hour and 20 minutes. After about an hour, I decided I'll add a little bit more nitric acid because it wasn't forming any strange colors like iron nitrate or anything like that, so I felt safe enough to add some more. It's also a very cold night where I'm at, so I needed to give it a little extra time to get the heat up. And after a few hours, it had cooled off, and I poured that nitrate solution off into a large beaker. I'm trying to keep most of the mass in the bottom of the beaker for another nitric acid treatment. It doesn't matter if a little bit of it gets into that big beaker because we will be filtering this anyways. And now I did a secondary nitric acid treatment, which is this right here. And I will now pour that into the beaker as well. And now I take that beaker of solution that I got from the 2 nitric acid treatments, and I'm going to filter it. And as you can see, that is all the powder that was in the bottom. So we're going to try and catch all of it in our filter. And once we've got all of that filtered, we're going to take that filter, we're going to add it to the beaker with the IC powder that we just processed, and we're going to form Aqua Regia. I'm going to use about 400 milliliters of distilled water. Going to use about 200 milliliters of hydrochloric acid. I'm going to use about 10 milliliters of sulfuric acid. And then I'm going to use about 20 milliliters of nitric acid. And I'm going to give all of that a pretty good stir. Turn on the heat. And then we're going to let that sit for about an hour. Should put a lid on it as well. It holds the heat in a little bit better. After about an hour, you can see it's changed colors. So we're going to pour that through our filter. As you can see, there's all this IC powder at the bottom still, so I figured it was a good idea to take this filter and add it back to that beaker and probably run a second Aqua Regia process. So when all of that is in the beaker, we add muriatic acid. I'm going to add about 15 milliliters of sulfuric acid. And we're going to add about 25 milliliters of nitric acid. Going to add the heat, and we're going to leave that for about an hour with the cap on it. Now, about an hour later, I took the cap off and I stirred it up. And then I put the cap back on it and let it go for a little while longer, maybe about 25 more minutes, before deciding to turn off the magnetic stirrer and the heat. Took the cap off and let it cool down for another 25-30 minutes. And then we poured that through the filter. Now I'm using hydrochloric acid to spray the filter clean. And then I'm using just water to spray the beaker clean. And once the filter is pretty much dry, and our solution is a nice yellow color, we can get that out of the vacuum beaker and into a large beaker. And that's all of our ash caught in the filter. So we pour all of our gold-bearing solution into a new beaker. And I thought it looked a little cloudy, so I decided to filter it again. And it's already coming through looking a lot cleaner. It was clean looking the first time I poured the solution through, but when we did Aqua Regia the second time, when it came through the filter, it kind of clouded it up a little bit. So now we can re-exchange beakers. We can put this solution into a bigger beaker. And I'm just going to sprinkle a little bit of urea into the solution. And then I pour in sodium metabisulfite dissolved in distilled water. Now, I wasn't present during the actual reaction. It happened at some point in the night, and there wasn't very much gold in this solution, but this is from the actual powder itself that came from those ICs. But there's also all the interior pieces. So I processed the interior bits the same way I did the IC powder. I just cleaned it with nitric acid, and then I refined it with Aqua Regia. I dropped the powder, and this is that powder right here. I pour a little bit of hydrochloric acid in that beaker, and then I poured that into the beaker containing all the foils that came off of the pins. I'm just going to add some more hydrochloric acid, and then we're going to boil that for an hour. After about a half hour, I decided to give it a little bit of a stir. But then after about an hour, you can see that all those filters have dissolved now. And the solution has changed to like a dark orange color. That'll be base metal chlorides that we're going to filter out now. And here you can see all those gold foils are stuck in one filter now. I'm just using hydrochloric acid to spray those foils down into the bottom of the filter while simultaneously cleaning any chloride salts out. And there you can see that's our filter full of gold foils and powder from the ICs. And now we're going to make Aqua Regia by pouring muriatic acid into the beaker. And we're going to use about 750 milliliters. And we're going to pour in about 10 milliliters of sulfuric acid. And then we're going to pour in about 20 milliliters of nitric acid. And like before, we're going to turn on the heat, put on our lid, and we're going to let that sit for about an hour. Here you can see all the yummy nitrogen dioxide fumes rising off of it. I do let it sit with the garage door open so that way it airs out, but I have to close it when I come in here because it's so cold. But I'm wearing a respirator. Here, after the full hour, you can see that familiar gold color is beginning to saturate the solution, so we're going to filter it. I had to straighten out my filter. And then we're going to use muriatic acid to, again, spray all the stuff that's in the top of the filter down into the bottom of the filter. And most of that dark stuff is different filters that have been dissolved. And they're catching little insoluble particulates in them and becoming darker. If you get too many filters dissolved, you start to have problems actually dissolving all of your gold properly, so it's important that you try to keep the amount of filters in this process to a minimum. It's okay to use quite a few actually, but you get beyond a certain threshold and it does start to cause problems. Now that we've filtered our Aqua Regia, we're going to pour in our sodium metabisulfite. And this one was tricky because I thought for a second that it just wasn't going to turn. And I walked away and it instantly turned into this brown solution, which is good. That's what you want, but I'm sad I didn't get it on camera. So we're going to let that sit overnight, and it looks like this in the morning. And that's all of our gold sitting at the bottom. So we're going to pour the solution off the top of that through our filter. And we're actually going to filter that solution about 4 times. And when we're done pouring off the solution, that's what it looked like at the bottom of the beaker. That's all gold powder. So we need to filter this so many times because, as you can see, there's gold powder that is clinging to that filter. And every time you filter this, it's going to get clearer and clearer. As you can see right there, it's still pretty cloudy. In the meantime, I'm going to spray distilled water along the inside of this beaker to rinse any base metal chlorides down into the bottom. We're going to boil it. We're going to pour that through our filter. And then we're going to use hydrochloric acid to dissolve those base metal salts from the bottom of the beaker. Because we just dissolved our gold previously using hydrochloric acid and nitric acid. If we don't use distilled water first, we could accidentally create a new Aqua Regia reaction with any remaining nitric acid salts or nitrate salts. So after we've rinsed it with hydrochloric acid, now we can boil it in distilled water again. to remove any of that residual hydrochloric acid we just introduced it. And because we're pouring all of this into the filter, we're doing the same cleaning process as we're doing in the beaker to the stuff that's in the filter. So we're going to pour this boiling distilled water through our filter. And you can see our gold powder is getting cleaner and cleaner, but it's not quite there yet. We're going to do muriatic acid one more time. Going to boil this for 45 minutes. And then we're going to pour that through our filter. Now we're going to clean any residual base metal chlorides out with more hydrochloric acid. And we're going to pour that through the filter. And now we're going to spray water in to rinse any hydrochloric acid out through our filter. And it's kind of important to spray the powder itself to release any residual hydrochloric acid caught within it. And now, as you can see, our filters are pretty loaded up with gold powder. And once your nice clean gold powder is all dry, you can either melt it there, or what I had to do is I'm splitting the yield of this, so I weigh out half the gold. So I weighed out the gold, and then I split that in two, and then I pour half of that weight into the top filter. And then we roll this filter up. And we pop it into a freshly heated crucible. Sprinkle a little bit of borax on top. And then lightly hit it with the flame to get that borax just to start melting. And that's going to help pull any of the gold down farther, so if the filter does blow away, it doesn't blow away the gold. But a nice advantage of using a wet filter is that it doesn't want to blow away very easily from the torch. So now that it's begun to be charred, you can hit it full blast with that flame. After you've burnt most of the filter off, though, you're going to want to resprinkle borax on. And now you can really give it to it. After a few minutes of burning those filters away, your gold should collect into one central point. Then you're going to sprinkle borax onto it. And you're going to try and fish it out of there, which always gives me a little bit of trouble, but I get it in the end. Oh bugger. Then you're going to quench it in water. I mean, you don't have to, but it helps to handle it. You're going to burn yourself if you don't quench it and try and grab it right away. And then we're going to pour our second half of the gold powder into the fine filter that's still in the Buccaneer funnel. What I've been noticing is the fine filter tends to catch more gold, and that's why these two beads end up being different sizes. I probably should have compensated for that a little bit. But nonetheless, sprinkle borax on your filter once it's in the fresh crucible so you don't blow your filter away. Here you can see some of the gold is already melted real nice. But we want it all in one spot. And right as it's starting to cool is usually the best time to pour the borax on. Come on, we can get you. Pretty nice gold beads, all things considered. So to get the flux off of them, we put them in a small beaker and submerge them in sulfuric acid. And you let it boil for about 50 minutes, and that is what you get. Nice clean gold. So the first one weighed 2.66 grams, and the second smaller one weighs 2.31 grams. I hope you guys enjoyed. Thanks for watching.